This is the first standard in grade 4 of the Common Core fractions. Here we want to extend our understanding of fraction equivalence and ordering. Specifically, we want to explain why a fraction a divided by a over b is equivalent to a fraction n times a over n times b by using visual fraction models with attention to how the number and size of the parts differ even though the two fractions themselves are the same size. Use this principle to recognize and generate equivalent fractions. So our goal here is to show that a over b equals n times a over n times b. And looking at specific numerical cases, 2 over 3 is equivalent to 2 times 2 over 2 times 3. 2 over 3 is equal to 4 times 2 over 4 times 3. And so on and so forth. So let's look at a visual model to see why that makes sense. Now, we are designating the area of this square, which is a 1 by 1 square, as the whole. And as we can see by the first figure, it is clearly 2/3. Now the next figure is still 2/3. It's still 2 over 3. Let me get that right. It's still 2/3. But because one horizontal line has been drawn through the middle, each third is now divided into 2 separate regions. Therefore, it is also 2 times 2 over 2 times 3. So we have shown that 2 over 3 equals 2 times 2 over 2 times 3. Now over here, again, each third has been divided into 3 regions. Therefore, we can multiply both the numerator and the denominator by 3. Each third is 3, so this is 3 and 3, 2 times 3. And for the whole, we must multiply 3 by 3. And the same argument gets carried out throughout, as you can see. Also, notice how one horizontal line is going to allow us to multiply both the numerator and the denominator by 2. 2 horizontal lines drawn allows us to multiply it by 3. 3 horizontal lines drawn by 4. 4 horizontal lines drawn by 5. And finally 5 horizontal lines drawn by 6. And of course we could continue this and the same result would occur. N horizontal lines allows us to multiply both the numerator and the denominator by n plus 1. Let's complete these results here. Let's just put the results right here. So A is clearly 2 over 3. B is 2 times 2 is 4 over 2 times 3 is 6. In figure C, we have 6 over 9. In D, we have 8 over 12. In figure E, we have 10 over 15. And in figure F, we have 12 over 18. But we can still view each of these as 2 over 3. Even though figure F has so many regions, this is still 1/3. This is still 2/3. Therefore, the figure can also be looked at as 2/3. So these are all equivalent. They're all the same. These are all equivalent fractions, we can see. This visual model I like because it makes it clear that we're successively, first we multiply by 2, we get the same result. Then we multiply both the numerator and denominator by 3, we get the same result. By 4, we get the same result. By 5, we get the same result. And we're at the point now where we can really envision drawing horizontal lines. If we wanted to show that 2 over 3 equals 7 times 2 over 7 times 3, we would have to draw 6 horizontal lines. Here we drew 5, so the next one we draw 6, and then 7, and then 8, and the pattern will continue. And it gives us a solid feeling that equivalent fractions are a solid theory. It does not matter what we multiply the numerator and the denominator by, provided they're the same, we'll get the same result. And I like this allows us to view it purely in terms of multiplication. For example, if I have 3 over 4, using the theory of equivalent fractions, I can say that that's equivalent to 5 times 3 over 5 times 4. So that equals 15 over 20. Here's our main result. A over B equals n times A over n times B. And there's no really reason to look at the division over here, because for example, if I have 5 over 10, I can say that's equivalent to 5 times 1 over 5 times 2, and therefore that's equivalent to 1 over 2. Right? I could, of course, use the reflexive property. We're so accustomed to looking at things left to right that let us write it this way as well. That equals A over B. So the theory of equivalent fractions allows us a lot of flexibility over here. 5 over 10 is equal to 1 over 2. 3 over 4 is equal to 15 over 20.